Hey, how's it going, guys? So here we are back again for the Python BACnet Stacks Playground, where we are doing some vibe coding on an analytics dashboard for HVAC systems. So this is kind of following like typical retro commissioning workflows, where in retro commissioning, that is an in-depth study of how the building operates over time. And my experience in that is typically like a really good retro commission project will do peak season heating system analysis and testing in the field. There's no testing in the field here. It's just the data analysis, and then a economizing season for free cooling diagnostics, economizers for airside systems. Where then if we were testing in the field, we would do rigorous validation that the air dampers on the air handling units close completely. All the actuators are sealing nicely. Um, so in our data analysis on that is kind of like we can do some stuff through data. And then the third thing would be an in-depth mechanical cooling season, peak mechanical cooling season. So three things: there's peak heating, peak economizing, and peak mechanical cooling. And this data set that we're working with, I have um, a full window of the economizing ranges. So it's like it's the data set is the end of heating season where boilers will start shutting off, and then we have a full range of the economizing season, spring in the Midwest, upper Midwest US, and then also peak mechanical cooling season, just the start of that up to about the 4th of July. So, in this part of the country, we do experience like very cold winters. So, like, picture lots of snow, lots of frozen lakes, below freezing for months on end. And then in the summer, there's like very high humidity for a short period of time where a lot of that warm, humid weather comes up from the Gulf of Mexico all the way up to almost to Canada. And we experience some very hot summers as well. For a short window of time, it can be like very humid. Okay, so where should we start now? So like what we're kind of playing around with is in Open-FDD, which is um, just the Open-FDD project online. There is a expression rule cookbook, which is basically everything that I can gather on the internet for deep research using ChatGPT. So ChatGPT has a deep research feature where it can chug away at something you want researched for. Sometimes it goes up to like 20 minutes or more. Um, so ChatGPT scraped everything on the internet about rule-based fault detection diagnostics, um, and it kind of built off of everything that was already into Open-FDD, which was originally the Guideline 36 fault detection rule set. So it kind of built off of that for everything that is known on the internet and in research papers that ChatGPT can get a hold of. So that's what we kind of fed into AI. So also just like data fusion, this is something that the Open-FDD product that is getting written in Rust will use SQL in the future. So there'll be like a dashboard where you put SQL to do fault detection rules against. And then also outside of the future Open-FDD that's not ready yet in Rust, you can do things in pandas. So this was the original Open-FDD concept was all Python pandas. So it's still there. It just won't be in the final Rust, which is a Rust as a coding language. So the newest version 3 of Open-FDD, which is a compiled Rust application, this won't use Python or pandas at all. But what is neat about Python and pandas is it's just an ordinary so pandas. So pandas is just a generic uh, Python. It's a Python data analysis, data manipulation tool. It's sponsored by this thing called NumFocus. So it's very popular uh, data wrangling library. So it's like for data frames, it's really good for tabular data. And AI knows how to use it really well. So you can basically do anything in pandas. Um, think of it as like a really big Excel spreadsheet that it turns your data into. So like I'm using CSV files, and then it's turning that into Pandas world, into a data frame, which is just a massive, really fast CSV file. Just think of it as like an Excel spreadsheet. Where then in Python and Pandas, it's a million times more powerful than you could do anything in Excel. And also, Pandas is also used in any modern data science thing. So, like all the data science competitions, um, they all use Pandas at some way, at some place in the data science process. Usually, it's loading the data, cleaning the data, manipulating the data, feature engineering of prepping the data set for machine learning. It's not the math libraries itself, it's just like data wrangling. And then what we're using right now is we're kind of creating rules in the data in pandas. So um, if you've been following along, um, so this is the pandas. So the SQL and pandas will be mirrors of each other. So you can write the same rules in SQL and get the same results um, in pandas as well. So it's just so basically we feed in all of this information to the AI agents, and it knows just what to do. For example, um, let's see, look at an easy one. So this is like sensor validation. So this is what it does in pandas. It looks at a column called zone temp. Then if the zone temp is less than 55, which would be degrees Fahrenheit here, and if it's not in between 55 and 90, that's where we would do a Boolean fault flag as fault. And then also, I'm also kind of using this. The fault condition has to be true for 5 minutes for it to flag, just to kind of reduce a little bit of the false positives potentially. So this is kind of keep that in mind. So SQL, you can do the same thing. So, but behind the scenes, we're writing all of our fault rules in pandas. Hopefully that makes sense. And then for these fault rules, there's just dozens of different rules that we can use. Duct static pressure, mixing air temperatures compared to outside air return air. And then a bunch of these are guideline 36. So like I have anything that's like FC, that's a guideline 36 rule. Some of these require design documentation from the records. So if you were using metric units, you would have to switch this to metric. So some of these will catch like leaking valves, chilled water valves, that kind of thing. Economizing when you shouldn't be economizing, or using mechanical cooling when you shouldn't be using mechanical cooling. So additional air handling unit patterns. Yeah, we should be. Okay, so like what I think I have now is also VAV box level data. So maybe we can look at some of these VAV box level faults. We're also trying to keep track of hours here. We're about 4 hours deep into this project. And, kind of, if we would bill out for this professionally someday, we kind of want to know about how much time. So here's some other rules for economizing when unfavorable. I think we should write this. So this is something I should ask for it to. So basically, the way that this rule is written, I want to change this in our little application here. So like, so economizing when outdoor conditions unfavorable. So like, this is outside air temperature and dry bulb. This is the outside air damper in percentage on the air handling unit. So this is a 0 to 100% damper actuator, which is typical. And this is saying when the outside air temperature is greater than 63 degrees Fahrenheit and dry bulb in the outside air damper is greater than 42%. It's just this wild assumption that the air handling unit is using free cooling, which is probably fine. You could even make the AI agent, if you have the data available, that what is the minimum outside air damper percentage. Usually there's a set point on the BAS for minimum outside air, and it's usually a percentage. Sometimes it can get sophisticated if the air handling units are newer and there is airflow measuring stations and airflow volume set point control. But classic is 20%. Sometimes what happens always is there is a test adjust balance contractor that sets that for whatever the mechanical engineer designed the minimum ventilation for people to breathe. So that's set and measured by a test and balance contractor. And then what happens all the time is very common is the maintenance staff monkeys with the set points over time. So keep that in mind too. So like what I want to do is one big project we did for algorithms recently is we used outdoor dew point for economizing logic. So we put this on an algorithm in Workbench, actually in a wire sheet in a big trading project where we scraped data from OpenWeatherMap API. I wonder if I have this. Maybe I'll just see if I can, not to get all sidetracked or anything, but like we, it would have been in here. So like in the Niagara Vibe Code Addict repo, we did a APIs. So we did an open weather block API. So like we used Open Weather Map. There's a little bit of Java code running in Workbench here, where we're just pulling out from the web dry bulb in Fahrenheit and then humidity in percentage. So with the idea that this data comes from a local weather station at the airport, so hopefully it would be slightly higher quality sensors than the local flimsy building automation sensors, which usually, more than likely, the local building automation sensors, especially humidity, outdoor air humidities, are garbage and never calibrated, so never trust them. So then in Workbench, you can feed this into a psychometric block and output dew point. So like we used, if the outdoor dew point is below 60 degrees Fahrenheit, which is like super safe for free cooling, the air is relatively dry. So anytime the outside air dew point is below 60, and then with a dry bulb high limit, so if the outside air dew point was below 60 and then the web dry bulb was below zone set point or 72, we could bring that air into the building, and more than likely, if it's in a dew point, economizing in like a dew point mode, where the dew point is okay, we would be in mechanical cooling and economizing at the same time, because the return air coming from the building would have more humidity. So like so basically this enhanced dew point logic, you can squeak out a little bit. It's less load on the chiller, basically. Hopefully that makes sense. So this is where we set this up. So if anyone wants this for a workbench, I think I even have in the final wire sheet too, that it would have this dew point logic in it. But if you're using metric units, you just have to switch your set points to metric. Hopefully that makes sense. Feel free to ping me. Also, if anyone out there too is using metric units too, like if you're using some of the vibe code app repo, like just hard code in here your variables, just to Google the conversion from convert 60° F metric, just copy this right into Workbench, and don't use the conversion in Workbench. There'd be another block where you convert it. Just don't do that. Just like hard code your Fahrenheit or imperial units to metric. Rather than converting the units in Workbench, it just gets really messy. But try and dumb it down. And then once your units are hard coded in metric, then it makes sense to you. Unfortunately, in the US, we are still on the imperial system, and the rest of the world has gravitated to metric. So maybe we'll be there someday too. I don't know. But for the time being, imperial units are so hard driven into my mind. Like it's metric units. When I see the data, it just doesn't make sense. I'm sure you're saying the same thing for me too. Okay, so where were we? So like so I want to make sure that my economizing when it's unfavorable is when the outside air dew point is less than 60, because we're factoring in humidity with that, and the outside air dry bulb is less than 72 degrees Fahrenheit. And this works really good for those rare instances in the Midwest when the outside air dew point is below 60. In this time of year in the summer is probably never. So if we would say Chicago dew point, like we're just barely, we actually had like kind of like a dry, the the outside air temperature last night got into the 50s degrees Fahrenheit, which is pretty rare for the middle of July. And that means that it's kind of some relatively drier air. So this is like right at the cusp. But in the spring and fall, when it's the dew point is really low, but the dry bulb temperature is still high, you can squeak out some more free cooling. So this is what I'm going to be using for my mask for economizing when outdoor conditions are unfavorable. I'm just going to keep this open. Okay, so so Open-FDD, I think I had this open. Why did I have this open? Yeah, so like just to recap, like we're not using data fusion, we're not using Open-FDD, we're not using Rust. This project is still in alpha. It's coming at some point in time. We are just vibe coding something outside of the Open-FDD application, just with AI agents in Python. I think that's all there was to say about that. Okay, then I also put this in a new vibe code app 19. So on the Python BACnet Stacks Playground, so we are in a vibe code app 19 of offline pandas, twin of Open-FDD pandas cookbook. So all this code will be here. on the internet. And then what I also did too was have Cursor put this into a soft AI agent software engineering spec. So the agents should know just what to do. And we're going to test that this morning too, because I'm actually starting on a brand new agent right out of this directory. So we'll test and see how it can get off the ground running fast. Okay, so this is the agent spec, actually. So it'll be kind of cool. So this is like what the previous Cursor agent wrote as an agent's markdown file, which is just a cheat sheet for the next AI agent, which could be you, which could be your Cursor, Claude, whatever you're using, Open, Claw, who knows. So basically, this is the prompt. You are an HVAC RCX analyst, Pandas engineer, Flask. Ooh, okay, cool. So this is, I haven't even read this yet. This is what the previous agent wrote for the next agent to hit the ground running. Pandas engineer. That was the analyst library. Mission to help operators, engineers, vibe code repeatable client-based CSV fault detection dashboards. Pretty cool. This app is not an Open-FDD Edge, it's an offline analyst twin. Well, with a Flask library. Data stays external. So this is something, yeah, the data is, there's too much data to push to GitHub here. So, which is good too, because like what people should be doing is just vibe coding their own. I have a feeling this is going to go into about 10 YouTube videos now. If we really want to do something bare bones, we should have, we probably could have done enough here, but there's a lot to cover. Rule implemented. So I don't know, this is cool. So there's even like a dashboarding spec. So yeah, this is neat. So this is all of the color themes, all of the way that the HTML is written. Plotly, that's the library that we use to make plots. Analyst panel. So like, I have a feeling we're going to be vibe coding a little bit more. I might even have two examples of this. Like one will be hard coded for this building 50 and 100, and whoever's data that is, that's probably good enough for you to just hard code that right into your data. But then for the rest of us, I was thinking a little bit, feel free to comment on it too, like maybe we could have a data model. This whole concept of having a data model, I'm still wrestling if we need this or not. But if we do have like a very generic app out there that could be customizable, then it's going to be maintained by AI. So we're not going to maintain this. We're just going to have the AI maintain it. Do we even need a data model or not? I don't know. I guess we'll find out. Because like, as long as we know from the client that the assumption is that you kind of know HVAC systems. So if you don't know HVAC systems, then you might need a data model because it could help you. But the bottom thing you do need is like VAV box to air handling unit relationships. And then I think the rest should be straightforward. As long as you kind of know how buildings are built. That is the biggest mystery, is like what air ducting in the building goes to what VAV box. And even if the client doesn't know that, but their maintenance team can sketch on a piece of paper, VAV box belongs to air handling unit this. Technically, that would be good enough for me. Because that's the assumption is that all chilled water systems are piped into the same cooling coils across to every air handling unit in the building. And then we just need to know feed relationships for air ducting, and that's good enough for my purposes. Unless you're getting into like really complex like chiller plants, where some cooling tower may not be common piped into the same chiller plant. Like stuff can get kind of weird in more complicated systems or hospitals or something like that. But the assumption is like this is just an ordinary office building. Um, okay, so enough of that. We have an AI agent spec here. So, and then we're gonna task cursor to be maintaining the spec as we make this dashboard more advanced, more advanced, more advanced. So like we'll keep on making sure that it's maintained. Okay, so I guess I'll keep that open. So I do have a new instance of cursor open. Then I'm currently on cursor settings, models, time of recording this video. The famous Fable 5 is out. Most powerful model, banned by the government. And Opus 4.8 and Sonnet 5. And I'm also still using Composer 2.52. So then I just have cursor in auto mode. So I don't know what the hell it's doing under the scenes. I have a feeling that these guys do all the orchestrating and then Composer does all the writing, which is fine by me because Composer, I think, is not as smart of a model, but it's still pretty smart. Like it's as smart as GPT 5.5, I think, by the metrics, but it's really cheap. So like the last couple of YouTube videos I've watched is Composer 2.5 dollar per API call or token or whatever how they bill it. It's cheap and probably good enough to write decent code. And then these guys that are expensive, I think, do all of the orchestrating. I have a feeling under the hood, I don't even know this, like it spins up a whole bunch of these agents and they're all doing something, all autonomously. So whatever, it's working. Okay, so we have a new agent. I'm just going to go to, I think one of these buttons is new agent. Okay, so here's an agent. New agent. Okay, so like let's do this from scratch. So like I'm just gonna go, we soak in this data, and we are also using the Pandas cookbook. This guy, I want to keep this tab open. Pandas. Right. Then I'm going to say, and then please fire up the application I want to inspect before we start enhancing. Oh yeah, then I have to say where we're getting the data from. This env variable should be set for the data location. Please check. And we are working with the building 100. Let me know if you have any questions. Okay, there we go. So fresh agent. It does not know anything about this project. So exploring lots of files. Thing I kind of like about this too is it shows its context usage. So let's see, I guess you can click on it. I haven't checked this out before. So it looks like so this little wheel down here will fill up as the agent's context window fills up. And as it starts ingesting more data, it's fills up in tokens. I think what happens is like the models only have a certain amount of um, memory before they just start forgetting stuff. And then for anyone not familiar with tokens, so that is in let's see. So I think the high level that I understand this, it's natural language processing. Their units is a token. So like think of a gallon of gasoline, gallons of water, uh, tokens for batches of words. So it's just their um, units that I think they, that AI AI is measured and built in, just like uh, just like gas or petrol at the filling station. So I'm kind of lazy these days, and like I even have it fire up the application, even though I have PowerShell open. The last old-fashioned way is you would have to write all the commands to run all the web applications, but it can just do it for you. Okay, so it's looks like there's internal server error. The Flask app returned a 500. So a 500, that's an error code in web applications. So maybe we can just do web application error codes. I'm not a web application expert, but I know enough to be dangerous. Okay, so we just had a 500. So like what we commonly see is this, a 500 is bad. Anything 500 is bad. Sometimes I see this 502. Um, I don't think we usually get into 400s. That's like more like yeah, a bad client request is a 400, which can also be that their security bad login or something. And then 200. So basically, just keep in mind 200 and 500. Those are the two error codes you'll probably most commonly see. Um, yep, there's 200, so that's good. 200 is good. That's success. And then a 500 is bad. Ooh, okay, so we probably had the last version running. So the AI was smart enough to know that there was an old version of this running on the computer still, and it killed it. A PID, us in HVAC, we're used to PID meaning, hey, we're making some damper or valve go back and forth on the proportional integral derivative control loop. Um, but in Linux and software engineering, PID is process ID, I think. So like, don't get them screwed up. Way different. Um, okay, are we up and running? See what it said. Okay, so building. Okay, Liberty building. Data range. We got data. Gosh, this is not the right data. We should have. Oh, we do have up to the 3rd of July on 5-minute grid. One question: do you have per VAV CSV elsewhere? Hmm. The server first hit a 500. Uh, this should be. I'm just gonna ask it to snoop around this data. Can you snoop around that um, location of the data for VAV box level info? Maybe I'll just have to ask the client. Okay, let's open an external browser. Check it out. So we're going to open up developer tools in Chrome. It doesn't look like anything is running yet. So we'll just have to wait. Oh, here it is. Okay, cool. Wow. Okay, so like I asked for the last time, um, zoom in a little bit more. So I asked for sliders so we can tune our fault rules. And then be able to type in notes. Settings saved. One little error says this favicon thing, which don't worry about that. Zone comfort. All right, so we have some new boy, there's just so much here again. So the web app is running. All right, so I'm gonna, should we do this? I think we should do this, right? Should we have this all at the same, all in the same place? Waiting. Maybe it's fine. So like what I want to do, cool. So it does actually look like there is. Okay, so it does look like there is, so there is VAV box data. Cool. Normally you'd want to either point. Yes, please bring over this VAV box data. Do whatever you need to do to combine it with all the other data. What is missing? Still kind of confused. Okay, so like one thing that I want to do right off the bat is economizing when outdoor is unfavorable. So I want to use this rule. So please also use this rule where I want the rule modified for economizing when unfavorable based on outside air dew point measured from the Open Medio Weather API data, where if dew point is greater, let's see, so data. Let's see, rule for economizer okay shall if the outside of air dew point is less than 60 F and the dry bulb all from open medio is less than 72 F, then the economizer is okay. We're then on HU systems, it should be in 100%. Okay, let me just think about this. Please revise this fault. We should also have a fault when mechanical cooling is running. Less than. Okay, sorry guys. So we should also have a fault for when mechanical cooling is running when economizer is when economizing is okay, that HU should be in a 100% side air mode. That's an assumption that when we're doing mechanical cooling and economizing at the same time, the air handling unit should be in 100% outside air mode. And when the economizing logic is not enabled, the HU should be in a minimum outside air mode. If you remember right, let's see, did we have the plots? I think we had, let me just see if I can find the plots. Oh. So these were the plots we were looking at yesterday. So if we just look at one of these air handling units, if they even have they don't even have a building pressure set point, duct static pressure set point. And I wonder if they have no minimum outside air damper set point. We currently don't know with a minimum outside air damper set point in percent. Let's assume typical 20%. We should not be economizing when outdoor air dry bulb, I'm just going to say, is less than 35 F as well. The assumption is like we shouldn't be. I've seen some buildings economize all winter long to cool off one zone in the building, which is like a rogue zone, and then it causes excess reheat energy in the from the natural gas system for the boilers. So we'll have that. Oh, and another thing I want is also please add in scatter plots to show outside air relationship to open. Let's see, outside air dry bulb relationship from Open-FDD data to HU leaving air temperature, chiller supply temp to Open-FDD dry bulb. On the chiller tab, and then boiler system, hot water supply temp, hot water supply temp to Open-FDD data. I should say always use Open-FDD web weather data in analysis versus the local sensor. I think I'm going to stop it after this, guys, and then I'll probably work with it for like maybe another hour and make the next video. Okay, so where are we? So then, and then also we should do the, so like these scatter plots will prove chiller supplier temp might have a reset for energy saving strategies. Air handling unit has a supplier temperature reset for energy saving strategies. And then same thing with the hot water boiler system. And then let's say, please also make a, I'm just going to say some kind of like a box or violin plot of the HU duct static pressure filtered and the fan is running to see if there is a HU duct static pressure reset algorithm in place. Yeah, what should we do? I just want to take one more look at this before we start doing some mega modifications. Revise the analyst set points for these features, especially dew point. I think I'll have to go back through all these charts and then completely modify it. Okay, so it did do this. Cool. This is what we asked for at the last time. So in 5-degree bins, all made in Plotly. So this is cool because in Plotly, you can do, hey, take a snip, and you can download a picture and it'll go right into your, you can paste it into your report. Right. So like mechanical cooling run hours by Open-FDD outside air temperature in 5-degree bins. So like what this is measuring is the chiller ran briefly when the outside air temperature is between 45 and 49. It ran some when outside air temperature is between 50 and 54. And then even these are run hours logged by the chiller. Technically, we could definitely be cooling. We could definitely be using free cooling below 60 for sure degrees Fahrenheit. So like these are direct hours, off the utility bill. And if you can't achieve like the free cooling during that time, there could be a performance issue with the mechanical system. Like maybe there's a VAV box not balanced or a broken damper somewhere, or the air handling of a fan is not working properly. Okay, so I think we're getting somewhere, guys. So I'm going to stop it here for this video. Okay, so I just want to definitely, incorporate on here. The dashboard plot. Please make sure we just logging chiller 1 and chiller 2. No need to display AHUs on this chart. And then we could actually make a Boolean flag to know when the chiller is running. Let's go to central plant. This dashboard is really slow. Still running. I think this dashboard is really slow because it's loading. Everything's loaded in CSV file format, so keep that in mind. Okay, so it is running daily chiller run hours. That's cool. Oh, it has this already. Oh, so there might be some redundant info here. Okay, so let's just see like when the chiller is ran. I'm gonna do it off of, oh, they do have a pump on. Cool. Okay, so like we have a pump on. Or else we could do actually by water temperature too. I've done that before. Chiller 1 pump on works. And let's try see if this guy's pump on status works too. Looks like it's working. I think. Some kind of fault in there, but okay, so it looks like we can just use the pump on as our flag. I can trust that data. Sometimes that these pump statuses don't work very well. It's unreliable, and then you end up just having to use that the chiller is running just based off of temperature. It also looks kind of funny. It's like this chiller 2 is 48 degree water that it maintains. What the other chiller is 44. I wonder if they are redundant chillers or if one is like a pony chiller, like a backup. So I'll find out. Okay, so like, let's just put that into here. Filter for chiller running based on the pump point for each chiller respectively. Okay, I think that should be good enough for today. I'm just gonna let cursor go nuts with this. And it can do this like really fast. What is kind of cool is that it AI can morph all this stuff, very fast. It's extremely efficient at how fast and how good these models are these days. And like I've even watched some other YouTube videos like the AI is trained in like so many different coding languages, and like it knows it's trained on the entire language of Python, like many different versions of Python. And then for making one tweak in one little line of code, it has all of that training. So it's can be incredibly much more efficient than the human software engineer, even though the human software engineer would probably make like, why would you architect, things, the way it does? But for making like one little line, tweak in the code, it's the other YouTubers are talking about it's very efficient at that because it can benchmark it across the entire thing that it's trained on, which is way different than, could be different than how the human approaches that same problem. All right, so it's chugging away. I might work with it a little bit before this next video, just so it's not so redundant, but it's just the same looking at the live dashboard and then just copy pasting, pushing it you're pushing, revise it, keep revising, that kind of thing. So I'll be doing that till the next video. Probably put another hour into it, but I think we'll have something cool here. So there's this is a science experiment, and then I think anyone else that wants to do this as well, that your AI agent, you can just beam it at where this is on GitHub, and you'll be able to hit the ground running faster, faster, faster. So another thing coming up on the Python BACnet Stacks Playground, before I get too lost in the weeds, is some people on the Open-FDD Discord channel. I guess that's on here too. So just go to Discord if you want to ask some questions. Is where are we? So like the Rust BACnet stack, which I am playing around with quite a bit. It's one of Justin's project. He's also very active on the Discord channel. So there's also people have been asking, what's the easiest way to get started in Python or in BACnet stacks, like on Raspberry Pi or in Linux? Is this BACnet stack in Rust has a Python API. Where'd it go? So like, oh, this is Rusty Haystack. It's the wrong one. Sorry. We'll also get into that as well. So Rust. Haystacks, another protocol we'll be diving deep into. Rusty BACnet. So not Rusty Haystack, Rusty BACnet. So like something I'm coming up soon is how to do pip install of the Rusty BACnet stack, then how to play around with it in in Python. Just so there is a easy button way for beginners to play around with BACnet in Python. And then the Rust stuff is way harder, so that's coming too. All right, until next time, I'll talk to you guys later. Have a good one.